So are we doing teaser too?
Yes, we are. I really don't want to see what come up here to the front here. Let's see if we can.
What are you here?
Okay, panel here.
Okay.
Okay. Well, the Astronomical League, I'm with those who, they have observing programs for observers. One's a telescope, and also have ones that may not have a telescope yet, but are really into the hobby and willing to help outreach and talk to the public. And the people that come there to maybe Niagara Zoo or the outreach events like the Wick, and be like a welcoming person to bring these people into the fold of amateur astronomy. And the basic award requires a minimum to attend 5 events, and each event has to be at least 2 hours long. But then it goes up there, and I'm sure that Pam is going to do that because she has won the outreach award at basic level for outreach, and we appreciate that with a certificate. And in my pocket is a dollar bill. He could call. Oh, and they provide a nice outreach certificate for you. And thank you for being there and welcoming people into these wonders of astronomy. Your smiling face and everything is really great. Thank you. Yes. So round of applause for Pam. Yeah, thank you. And we appreciate all the hard work that you do and being there to help people and welcome people to the astronomy events.
Very much.
Thank you.
Thank you. All right. All right, now, Chuck, can you hear me out there?
I can hear you loud and clear.
Excellent. All right. Well, if you'd like, please, I'm going to turn off my screen share. And if you'd like to share your screen, then we'll start your presentation.
Okay, very good. First of all, let me thank you for inviting me to be with you. You are one of only about 3 or 4 clubs who have been continuously in the Astronomical League since its inception. As you know, the league formed in 1941, and then Pearl Harbor happened, and so we reformed shortly after the war. But you are certainly recorded among the 13 original societies, only about 3 or 4 of which are left in their then existing form, to be a part of that. I'm sorry? Oh, I thought someone had a question. Anyway, I wanted to just express my appreciation to your club for your loyalty over these many years.
Do you need the questions now?
Okay, I'm sorry. Was somebody asking a question? I'm sorry, I heard a voice there. I'll just ignore that. I'd also like to welcome Alan to our council. He is our new Northwest chair, as you know, and hope we'll be seeing him in our council meetings. And again, thank you very much for your long-term participation. I'd like to tell you a couple things about the league. We now have a new website up. This has been a multi-year project with professional developers involved. And it involved a transfer of our website from the Drupal platform to the WordPress platform. And the reason we needed to do this is because Drupal sunsets about every year. That's about $9,000 a year to update it. And we only have one person that is capable of updating our entire website as a result.
Hey, Chuck?
Yes.
Could you hold up just a second? We're having some technical problems here.
Okay.
And we can, I can see it on my computer here on the Wi-Fi, but our audio is not working here on the screen that we have in the room. So just, can you hang on just for a second?
Absolutely. Take your time.
There we go. Now, how do we get the sound? How do we get the sound? Down here. That's our sound. So how do you do that? With the mouse.
Where's my mouse? My cracking myself. Yep, click there.
Audio's too low. How about now?
Try it now.
You want me to speak now?
Yeah, say something, just say
Yeah.
something.
Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Testing, testing.
Hold on. There it's.
Okay, say something now.
Okay, the Popular Astronomy Club has been in the league for a total of 82 of its 87-year history.
Where was the TV remote? This is it here.
Yes.
There we go. Turn it.
All right, sir, can you try talking again, please?
Absolutely. I just wanted to express my appreciation to your club for its long-term loyalty to the Astronomical League over these last 82 years.
Good.
Is that better?
Yeah, that's better.
Okay.
Thank you.
Thank you.
This happens at every meeting, including our own. So I understand the problems. I was talking about the website. We have a new website that's up. It has a lot of broken links still because we're still populating those links. So give us some time on that. But we are populating it very rapidly because we now have 8 people who are qualified to help update our website. A lot of clubs, perhaps including your own, have had trouble in the past getting things updated on the old Drupal site because it was one person trying to update 315 clubs, not to speak of all the award database information and rosters and so forth. So we've incorporated the league store into our website now as well. So as soon as everything is populated on that site, it's going to be a dream for us to keep updated, and we look forward to doing that. So now I will go ahead and share. Is the audio still good?
Yeah.
Okay. All right, let me go ahead and share screen. Okay, can everybody see that okay?
Yes. Yes.
Oh, great. Okay, what we're going to be talking about tonight are records. We're going to be looking at the furthest, the closest, the hottest, the coldest, the largest, the smallest, the first, the brightest, the darkest, the fastest, things that have set records in astronomy and space travel. We're going to do this from the Earth and work our way on out. So space travel will obviously populate most of the early part of these records. This is easy listening, but there are a lot of different records involved. And so maybe a few of them you won't be familiar with. I hope that would be the case. The first one I want to talk about is the coldest place in the universe ever. And that is actually a place on Earth. It occurred at the University of Bremen in Germany on August 30th of 2022, when Christian Deppner and his team were able to matter wave lens rubidium into a Bose-Einstein condensate and get it down to within 38 picokelvins of absolute zero. Of course, absolute zero is not attainable, but you see here in the middle how close they came. And no place in the universe is known to have been colder. But of course, that was back in 2022, and just for that one day. The largest refractor in the world remains the 40-inch at Yerkes Observatory. It's a 40-inch f/19. The tube is 60 feet long. The lens, the doublet at the top end, weighs 485 pounds, and it's located in Lake Geneva, Wisconsin. As you know, at one point they were talking about raising the entire observatory and putting condos in. That was stopped And now the observatory has actually been refunded and is going to be doing research again. So it has been saved, as it well should be. It's one of the most iconic locations in astronomy, in my opinion. The largest reflecting telescope, single aperture reflecting telescope in the world is the Gran Telescopio Canarias in the Canary Islands. It has a 409-inch diameter segmented mirror and gathers 4 times the light gathering power of the Mount Palomar 200-inch Hale telescope. Now, the largest reflector in the world with combined apertures is the Large Binocular Telescope at Mount Graham in Arizona. It has twin 330-inch mirrors, which is an effective aperture of 465 inches. Soon, however, these records will both be eclipsed by the extremely large telescope in Chile, which will have a mirror 1,547 inches in diameter. An incredible 129 feet in diameter, and it should open in about 2025. Well, what about the hottest place in the universe ever? By the way, this is the projected extremely large telescope that will open in about 2 years. The hottest place that's ever been achieved in the universe is also on the Earth. That, of course, is in the Large Hadron Collider at CERN. Lead ions were accelerated to 99% the speed of light and created a quark-gluon plasma that achieved a temperature of 9.9 trillion degrees Fahrenheit. That's about 5,500 times hotter than the core of a supernova. The worst space-related disaster occurred on the ground. It involved this rocket, the R-16. It was being tested. And a General Netherland was in charge of the operation, and they had a little problem with it. The second stage was acting up electrically. General Netherland decided to go out and deal with the problem himself because they wanted to get this rocket launch off before a big celebration in Moscow. And when he went out, of course, all of his underlings decided that they needed to show interest by going out with him. And so a whole bunch of people went up to the second stage and began tinkering around and accidentally ignited the second stage engine on top of the fully fueled first stage. The result was a catastrophe that killed 92 people and injured 49 others. This was in October of 1960. The only deaths in space are actually those of 3 Soviet astronauts aboard Soyuz 11. They were Georgy Dobrovolsky, Vladislav Volkov, and Viktor Patsayev, in that order as you see them here. And their cabin on Soyuz 11 depressurized in June of 1971. They're the only people who've ever died above the Kármán line, above 100 kilometers. The largest impact crater on Earth that has been confirmed is still Verdafort, which is 190 miles in diameter and is in South Africa. It's approximately 2 billion years old. You can see the hills that form a circular rim to this very large crater. A larger one was suspected in Antarctica, but it's never been able to be confirmed since then. The largest radio telescope is now the Eye of the Heavens in China. It's in Jinke Village in Guizhou. Went into operation in 2016, and it's exactly half a kilometer in diameter, 500 meters. The oldest astronomical, excuse me, the oldest astronomical observatory appears to be Wurdi Youang, Little River, Victoria in Australia. It's an Aboriginal Stonehenge, and it's 11,000 years old, according to dating that's taken place there. There are only a few remnants of it left. The first animal in space was aboard Sputnik 2, November the 3rd, 1957, and that was Laika. And Laika was also the first spaceflight fatality. She was basically euthanized after 5 hours aboard the spacecraft. The first man and woman in space also go to the Soviets. Yuri Gagarin, of course, made 1 orbit on April 12th of 1961, and Valentina Tereshkova made 48 orbits from June 16th to 19th, 1963. The first human spaceflight fatality was Vladimir Komarov. He did not die above the Kármán line. He had died on impact with the Earth on April 24th, 1967, when his parachute failed. There were 203 structural flaws with the Soyuz 1, which he flew. And his very good friend, Yuri Gagarin, wanted to take the mission from him because Gagarin felt that it was going to be a fatal mission because of all the structural flaws. And he proved to be correct. Gagarin was not allowed to take his place, however, because he was a national hero and they didn't want to take the chance. The most time in space, again, a Russian, Gennady Padalka of Russia, spent a total of 879 days in space. That's 2 years and 89 days of his life over 5 flights. The longest single space mission also belongs to a Russian, Valery Polyakov. He went on a mission that lasted 437 days, over 7,000 orbits of the Earth. The most times in space, 7 missions, belong to 2 American astronauts, Jerry Ross and Frank Chang Diaz. The first person to enter space twice was Joe Walker. He flew on 2 X-15 flights numbers 90 and 91 in August of 1963. Both of them went above the Kármán line. And he was killed when his F-104 flipped the tail of an XB-70 Valkyrie in 1966. This was part of an effort on his part to take photographs of the Valkyrie. It was a publicity effort, a photo shoot that was not authorized, and several colonels' heads rolled as a result of this accident. The first time more than one person went up on a particular rocket was the Voskhod 1 in October of 1964, when Vladimir Komarov, Konstantin Fektitov, and Boris Yegorov went into space together. And the first spacewalk, of course, was Alexei Leonov aboard Voskhod 2 on March 18, 1963. And that picture that you see there was all over the international news at that time. The human speed record belongs to Apollo 10, Tom Stafford, Eugene Cernan, and John Young, returning from an orbital mission around a non-landing mission around the moon, entered the Earth's atmosphere at 24,846 miles per hour on May 26, 1969. And that is the fastest that humans have ever traveled to date. The human altitude record still belongs to the Apollo 13 astronauts. Because of the nature of the free return trajectory around the moon, they looped pretty far beyond the moon, which was close to apogee at the time, and reached a distance of 249,205 miles. It would be a record that would be easily broken, actually, but nobody has bothered to do it. The first unmanned landing on another world occurred when the Russians landed Luna 9 on the moon on February 3rd, 1966, and snapped this particular photo. The first manned landing on another world, we all know what that is, of course, Apollo 11, July 20th, 1969. The longest stay on the moon, Apollo 17, 3 days, 3 hours. And Harrison Schmitt, we had the privilege of meeting at our national convention last year, has got to be the friendliest astronaut I had ever met. I've met about 7 or 8 of them. He actually stayed around signing autographs and taking pictures with people until the people started drifting away. Incredibly nice man. Well, moving on from the longest stay on the moon, we want to talk now about the highest known mountain. And the highest known mountain obviously would still be in the solar system, and it's not Olympus Mons, it's actually Rhea Silvia on Vesta, which rises to a height of 72,178 feet above the average surface level of I guess we call it the average radius of Vesta. It's about 100 meters taller than Olympus Mons in that regard. The first unmanned landing, by the way, here's an interesting comparison of mountain heights for you to look at. We've got Rhea Silvia marked up here at the upper right. Olympus Mons, which is a huge Arizona-sized hump, marked here. The equatorial bulge and the Iapetus being the third highest, and Buenos Montes on Io being the fourth. So you have to come all the way down to a lowly 29,000 feet on Earth before you find something you're familiar with here. The first unmanned landing on another planet occurred on December 15, 1970, when the Soviet Union landed Venera 7 on the surface of Venus. The parachute actually melted somewhat several hundred feet above the surface, so the vehicle had to land rather hard. Nonetheless, it was able to function for about 20 minutes in 887-degree Fahrenheit conditions and transmit pictures back to Earth. The pressure, despite the 887-degree temperature, the pressure was equivalent to being approximately 3,000 feet deep in water, 90 atmospheres of pressure, crushing pressure. The largest known crevice or canyon, still Valles Marineris on Mars, 2,700 miles long. It spanned the entire United States from coast to coast. The fastest spacecraft ever is the Parker Solar Probe, which in 2021 achieved a speed of 364,660 miles per hour. It passed within 6 solar diameters of the surface, and had you been aboard, the sun would have filled nearly 9 degrees of the sky. If you think that sounds warm, you're right. The first asteroid landing was the Near-Shoemaker mission to Eros. The landing occurred on February 12th of 2001. At that time, the asteroid was 158 million miles from Earth. And here's a picture taken by that mission from the surface. The first landing on a comet occurred when the Rosetta mission's Philae lander landed on 67P Churyumov-Gerasimenko, this incredible comet, on November 12, 2014. And here's another image. The greatest comet impact known, the G impact of Comet Shoemaker-Levy on July 18, 1994. It struck Jupiter with the equivalent of 6 teratons of explosive force. That's 5 million Hiroshimas, or 4,000 Castle Bravo hydrogen bombs. And had it hit, say, in Texas, this is the realm of the damage that would have been caused. Obviously, it would be an extinction level event. The most volcanically active world known is Io, Jupiter's moon Io. It's in constant volcanic state. What you're seeing here is a volcano called Svashtar, which is emitting a 190-mile tall plume. This image was taken by the New Horizons mission in 2007. The largest known impact structure appears to be a 4,836-mile diameter impact structure on Jupiter's moon Ganymede. It would have involved an impactor approximately 50 kilometers in size, and it was discovered by observation of a global system of furrows. The Japanese researchers discovered this in May of 2020. The largest known storm that's ever been observed is not the Great Red Spot on Jupiter, but rather the Great Springtime Storm on Saturn, which raged from December of 2010 until August of 2011. It covered 1.5 billion square miles, more than 8 times the Earth's surface, and extended 9,000 miles by 186,000 miles. And here you see an image below showing you the entire width or diameter of Saturn and the width of the storm in relation to it, or I should say the length. The most distant unmanned landing was the Cassini mission's Huygens lander, which landed on Titan on January 14th, 2005. At that particular point, this Saturnian moon was 885 million miles from Earth. And this image was taken from the surface. There's a good video of this landing online on YouTube if you'd like to watch the entire mission as it descends and lands on the surface. The tallest known cliff is Verona Rupes on the Uranian moon Miranda. It is 63,000 feet high, about 12 miles high. This moon was destroyed and recollected, so it's like a bunch of baby blocks that have glommed back together due to gravitational attraction. So there are a lot of very strong cliffs and cliff-like features on this world. If you jumped off of this, you'd be going very, very slow for quite a while, and it would take you 12 minutes to land, but it would be an unfortunate landing. By the time you got to the bottom, you would have achieved 124 miles per hour. The most distant photo taken of the Earth, of course, is the famous pale blue dot photo that Carl Sagan made quite famous, taken by Voyager 1 when it was 4 billion miles from Earth. And the furthest man-made object is Voyager 1. It was launched in 1977, is traveling at 38,000 miles per hour, and is currently 14.9 billion miles from the Earth. That's about 1/2000th of a light year, and that's over 46 years of journey. If it were aimed at the Alpha Centauri system, it's not, but if it were, it would take 76,000 years to reach it. It's probably going to lose power ultimately in about 2025, so it's only got a couple of years left at best. The nearest star to the sun, of course, is Proxima Centauri. It's a red dwarf that orbits two sun-like stars in a very long, lazy orbit that takes some 550,000 years. But that orbit has brought Proxima closer to us than Alpha Centauri A and B. It lies 4.25 light years away, about 25 trillion miles. That's about 8,330 times further than Pluto. If you were on its planet, Proxima B, looking back at in the direction of the sun, you would see Cassiopeia much as we see it. Alpha Centauri is only 4 light years away after all, but you'd see one extra star. The brightest star in Cassiopeia would be the sun, and it would appear to be located in the Heart Nebula. And it does have a planet, Proxima B. Proxima B orbits in a habitable zone around Proxima Centauri. There is another planet, Proxima Centauri C, but currently that planet's further away than Proxima B. So Proxima B holds the record now as being the closest planet to our solar system other than planets in our solar system. It's only slightly bigger than the Earth, about 1.17 Earth diameters. And while it is in the habitable zone of Proxima Centauri, that's not necessarily good news because red dwarf stars tend to be flare stars, and Proxima Centauri is a flare star, which means that this planet would be showered with intense radiation periodically, not exactly hospitable to life. The closest supernova remnant to us is one that we are in. It's called the local bubble. It's about 300 light years in diameter. The result of supernova activity that occurred between 10 and 20 million years ago in a group called the Pleiades Moving Group supernovas. This particular bubble formerly was known as Jaminga. The most, here's a graphic that shows you our local bubble. Again, about 300 light years in diameter. The most sun-like star. This is visible to the unaided eye. It's called 18 Scorpii. Shines at magnitude 5.5. It's 45 light years away, and no planets have been detected around it so far, but that may be because none are transiting. The orbits don't bring them into transit over the disk of the star. But notice down here that the mass, luminosity, diameter, temperature, rotation, and age of the star is almost absolutely identical to that of the sun. So if you want to see what the sun looks like from 45 light years away, take a look at 18 Scorpii. Next, we want to talk about the largest apparent diameter of any star. And that record, of course, belongs to the sun, which occupies half a degree of our sky. But other than the sun, the largest disk of a star is that of R Doradus, which extends to a diameter of 0.057 seconds of arc. Mira just slightly smaller, and Betelgeuse just slightly smaller than that. The size of Pluto is marked on here to show you how small these disks actually are. The smallest known planet is Kepler 37b. It orbits the star Kepler 37 in Lyra at 215 light years. It has the size of the Earth's moon. Here's Kepler 37b compared to our moon and to Mercury. It has an 18-day orbit around its star and has a surface temperature of about 800 degrees Fahrenheit. The largest known planet that is not regarded as a brown dwarf is Rox 42b. It has about 9 Jupiter masses and about 3 times the diameter of Jupiter, and it orbits the star Rox 42b in Ophiuchus, which lies at 440 light years distance. Here it is over here on the right. The darkest known planet is TRES 2b. It orbits Kepler 1, a star in Draco, 750 light years away. It's about 1.25 times the diameter of Jupiter and has less than 1% albedo. It reflects less than 1% of the light that strikes it. The closest black hole to the Earth is actually paired with a star. It's called Gaia BH1. It lies at 1,560 light years. Its sun-like star and black hole orbit each other with a period of about 185 days. The black hole has a mass of about 10 suns, and the diameter of its event horizon is about 34 miles. The most symmetrical non-spherical object that has been detected in space is the red rectangle in Monoceros. It lies at a distance of 2,300 light years. Just look at this planetary nebula and its incredible shape. You're actually seeing this tilted in its orientation toward us, the left side being closer to us than the right side in this image. The most planets around a star, well, we used to have that record all to ourselves with 9, but when we demoted Pluto, Kepler 90 joined us at the top with 8 planets. Kepler 90 is a star in Draco. It lies 2,790 light years away. The coldest place in the universe now, not in Bremen, Germany, when you're making a Bose-Einstein condensate, but the coldest place in the universe now, and continuing, is that of the Boomerang Nebula in Centaurus. It lies 5,000 light years away, and because of the rapid outflow of gas and expansion of that gas, which is exiting at 310,000 miles per hour from the core, the temperature in the gas is about 1 degree Kelvin. The furthest natural satellite ever detected is that of Kepler 1625 HI, which lies about 8,200 light years away. Now, what we're talking about here is an exoplanet that was discovered transiting the star Kepler 1625. But when we observed the light curve drop, it dropped a little bit more for some reason, and it was believed to be as a result of a moon of this exoplanet also transiting the star behind the planet. And this is how it was detected. The largest natural satellite belongs also to this very same most distant natural satellite, Kepler 1625 HI, that I just spoke about. It's a little bit larger than some of the largest moons in our solar system, and I'll show you how big it is. There it is, Kepler 1625 BI. some 48,450 miles in diameter, would make a very respectable planet in our solar system. In fact, it would make the third largest planet in our solar system were it here. And so that's why we were able to detect it transiting that distant star. The hottest known star is a Wolf-Rayet 102 star in Sagittarius. It's at a distance of 9,400 light years, has about 60% of the radius of the sun, and it's embedded in this nebula. But the surface of the star is 378,000 degrees Fahrenheit. That's compared to the sun's 10,000 by comparison, just right here in the center of the image. The fastest spinning star belongs to a pulsar, PSR J17482466 in Sagittarius. It's 18,000 light years away. It spins at 716 times per second. That's 24% the speed of light at its equator. The largest known star is this one, right in the center of the image here. It's Stephenson 2-18, lies in the constellation of Scutum, 18,900 light years distance. The diameter of this star is 1.8 billion miles. And to show you how big it is, here is the orbit of the Earth around the sun by comparison to the star. It would engulf Saturn if it were centered on our sun. The fastest moving star is S4716. You can see it here, whipping very rapidly. It's this bright one in the middle, right here, as it loops very rapidly around Sagittarius A star, the black hole at the center of our galaxy. It achieves at perigee, rather, perihelion to the black hole. I don't know what the term is for being close to a black hole. 8% the speed of light. This obviously is very close to the center of our galaxy, so it's just over 25,000 light years away. The furthest detected exoplanet belongs to Sweeps 04, lies at a distance of 27,710 light years. It has about 3.8 times the mass of Jupiter and is further than the center of our galaxy from us. So that's how amazing our detection of exoplanets has gotten in recent years. The closest galaxy to the Milky Way is actually one that is entwined with it. It's the Canis Major galaxy. Its core is about 42,000 light years from the core of our galaxy. And it was detected by the two-mass survey. It's obviously a galaxy that approached the Milky Way and has been absorbed by it, but has still many very tenuous arms that are visible as a result of the collision. The fastest spinning star, VFTS 102 in Large Magellanic Cloud, lies at 164,000 light years, and it is spinning at 1 million miles per hour at its equator. That's about 100 times faster than our sun. The largest known spiral galaxy belongs to the Condor galaxy, NGC 6872 in Pavo. It's 522,000 light years long from tip to tip of the spiral arms. This one's interesting. It's the loneliest galaxy we've ever detected. It's MCG 0102015 in Boötes. Lies at a distance of 293 million light years. Lies in the middle of the Boötes void. There is no galaxy within 100 million light years of this galaxy, which means that were humans to have lived on this galaxy instead of in the Milky Way, we would not have been able to observe other galaxies until the early 1960s. We wouldn't have even known they existed. The largest known galaxy is IC 1101 in Virgo. It lies at a distance of 1 billion light years. It has approximately 100 trillion stars, about 500 times the mass of the Milky Way. Its halo is over 4 million light years wide. Bear in mind, that's larger than the distance between the Milky Way and Andromeda. Well, we talked about the hottest place in the universe at any time in history being at CERN, but the hottest place now is the galaxy cluster RxJ1347 in Virgo. Lies at a distance of 5 billion light years as we move on out further. And the temperature achieved in this cluster reaches 300 million degrees Kelvin. The brightest star in the universe is Godzilla, and you see it as a bright point in this gravitationally lensed galaxy. Galaxy has a really sexy name of PSZ1G31165-1848. Please try to memorize that. Lies at about 5 billion light years and is 120 times the mass, the luminosity rather, of the sun, 120 times. The largest known black hole, that title belongs to Phoenix A in the constellation of Phoenix. It lies at 5.8 billion light years from Earth. It has a mass of 100 billion suns. That is about 24,000 times more massive than the black hole at the center of the Milky Way, and about twice the mass of the entire galaxy M33. The diameter of this black hole is 366 billion miles. And way down here in the center, there's a little tiny oval you can barely see, and that oval represents the orbit of Neptune by comparison. This has there's a term that applies to black holes of this size. They're called slabs, and slab stands for stupendously large black hole. The most massive galaxy cluster known is called El Gordo, or the fat one. It has 3 quadrillion stars in its assorted galaxies and lies at 7 billion light years distance in the constellation of Phoenix. What about the furthest naked eye object, the furthest thing that humans could ever possibly have observed? And it's not clear that anyone ever did, but you could have. If you had been looking at just the right place in the constellation Boötes on March 19th of 2008, you might have seen GRB 080319b. This, of course, is a gamma ray burst. It achieved magnitude 5.5, and it stayed above magnitude 6 for about 70 seconds. Had you seen it, you would have observed something at a distance of 7.5 billion light years with your naked eye. Again, there's no record that anyone saw it. The largest known structure in the universe is the Hercules Corona Borealis Great Wall. Lies at a distance of 10 billion light years and has a size of 10 billion by 7 billion light years. It's a series of gamma ray bursts in Hercules, Corona Borealis, Lyra, Boötes, and Draco, and it spans 1/9 of the diameter of the observable universe. The brightest known object in the universe is quasar APM 0827952555 in Lynx. This is a fascinating object. You can observe it with a good-sized Dob. It shines at magnitude 15.2. And when you observe it, which is exciting to do, and I encourage you to try, when you observe it, you will be stopping photons that have been traveling toward you for 12 billion years. This has the mass of 12 trillion suns. This particular quasar also has the honor of being the wettest known place in the universe. It has water content equal to 148 trillion times the water content in all the Earth's oceans, all of it going right down the drain into the black hole. What a waste. California could use some of that. The furthest known galaxy for a while was thought to be Sears 93316 in Boötes, which was being reported out to lie at a light travel distance of 13.6 billion light years. This is in a universe that's only 13.82 billion years old. However, more spectroscopic examination of this record determined that it was actually had a light travel distance of only 12.6 billion light years. And so the current record holder remains HD1 in Sextans. This has a light travel distance of 13.463 billion light years, And that means that you're seeing this galaxy as it existed barely more than 300 million years after the Big Bang. The furthest distance that we can possibly communicate with, that is to say, if we sent a signal to a galaxy, how far away could we possibly expect our signal to reach that galaxy? The fact is that any signal leaving Earth at the speed of light could only reach eventually a galaxy that lies today within 16 billion light years of the Earth. This is called the cosmic event horizon. Anything beyond 16 billion light years is unreachable. That is, we can't get a signal to them, they can't get a signal to us. It means that all those galaxies you see in the Hubble Deep Field, and most galaxies that we see are well beyond 16 billion light years. Most of them, for example, the furthest galaxy, HD1, its light left that galaxy when it was much closer to Earth. That light traveled to us for 13.46 billion years, and today it lies out at 33. So when you look at the Hubble Deep Field, it's filled with galaxies that are actually today at distances like 20, 25, and 30 billion light years. Most galaxies lie beyond the cosmic event horizon, and we cannot communicate with them. This means that the last photons that we will ever receive from those galaxies left those galaxies long ago. They're still flowing in. You can still observe them and still take your Hubble Deep Field and image them, but they're time limited. And then there's the question about what is the furthest distance that we can possibly see? This is obviously the end of the program. And that distance is 46 billion light years. It's called the cosmic particle horizon. If there had been a galaxy shining right after the universe became transparent, shortly after the Big Bang, that would be light that has taken the full age of the universe to reach us, 13.8 billion years. That galaxy today would lie at 46 billion light years. So that is the location today of the furthest things that we can see today. And that completes all of the records. I guess you could call those the Edwin Awards for all the records that exist in astronomy and space travel. And I'd like to be able to answer questions in detail about any of these particular records, but it's an awful lot of records, and I can't guarantee you I will have detailed answers for you, but I'll try. And with that, I will stop share, and thank you for inviting me. Thank you.
Thank you, Chuck. That was a great presentation. Lots of interesting information. Now, do we have any questions from the audience? We got one in that.
I'm not able to hear.
The destruction rocket that exploded and killed 92 people. Is that the rocket that had 32 engines?
Can someone repeat the question for me closer to a microphone?
He asked if the Russian rocket that killed the 96 people, did the engine have 32 thrusters on it?
No, this was not the N1. This was actually a military rocket, an ICBM, but it was. We don't leave rockets fully fueled when we go out to service them. We drain all the fuel out, scrub the launch, move the launch back several weeks. The Russians were in a hurry because of the celebration in Moscow. They wanted to get this rocket launch off for Nikita Khrushchev before that celebration. And so they left the rocket fully fueled and went out, and disaster ensued. But it was not the big N1 rocket that had such colossal failures for them, their moon rocket.
Yeah, the N1 was Russia's attempt to reach the moon. And again, it didn't make it.
Correct. They had constant instabilities. I think there's at least one YouTube showing an N1 launch failure. It got pretty far up before it blew up, but eventually it went bad.
Any other questions for Chuck?
That's a very nice room you have there. What kind of center is that?
John Deere.
Yeah, this is the Catherine Butterworth Center. And she was, one of the daughters of John Deere.
Oh, okay.
And so this house was built, I don't know, in the 1880s or something like that. And now it's used for groups like us, nonprofits, to come in and have meetings.
That's fantastic. It looks very nice. Perfect meeting room.
Well, thank you again, Chuck. Again, it was a very interesting presentation. We'd love to maybe put a copy of that up on our website if we could.
Sure, absolutely.
Excellent. In the meantime, we'll get on then to our next bit for our meeting. Now we have new activities on schedule. First of all, we've got Carl Wenning. He's going to be talking about his image intensifier, and that's going to be on August 7th. And he's going to be at the Windmill Restaurant. Al's reserved a room for us there. And if the weather is good, after that, we're going to go out to the Paul Castle Observatory and take a look at the device in use. Also coming up, we have the Butterworth Center is having a porch party. This is September 17th. I believe that's a Sunday. And we're looking for some people to help and participate on the porch party and present Popular Astronomy Club to the public here at Butterworth Center. We've got another program coming up at the East Moline Library. Again, this is going to be October 30th. Not all the details are figured out yet, but we'll probably be in the same location that we were last year, which is a small park near the East Moline Library.
That's Runners Park in East Moline.
Yes, that's the one. And so we'll take a look at that as that pops up. More details will be worked out with that. Okay. This month we've got Niabi Zoo on the 15th, so that's next Saturday. If it rains, we're going to the 22nd. On the 25th, we're at the DeWitt Library. We're going to be at Westbrook Park. And that'll be Tuesday night, July 25th. Again, Niabi Zoo, August 19th. The rain date is 8/26. Again, if it rains, we go to that one. And then September 12th, we've got the Riverdale Schools. The program is expected to be behind the middle school itself. This will be at sunset time, but we still need to confirm some of the details with the school. So we'll have that up on the website. We'll let the rest of the club know as soon as we have more information. Then Niabi Zoo on the 16th, of course. Niabi Zoo on October 21st. Then the East Moline Library, as we mentioned before, on the 30th. We do have a rain date for that on 11/3, if that works. Niabi Zoo on the 18th. Now, we've got some outreach programs coming up, and this one, this is the St. Mary Monastery, and this is their Starry Night and Wondrous Day Retreat, which will be on September 8th. Now, this is for our club to help and participate. It's not something we necessarily share with the public per se, but club members are welcome to join, and we'll have some more details on that. Again, in the future, we'll let you know some more about that as well. Again, we talked about the porch party, Moline Library, the John Deere Middle School fall program, and so on. And now we still need individuals to write more of the Skywatch articles for the newspaper. I know we've all been busy this last month and a half. It's been busier than usual for us as a club, but we still need some people to write articles. So if you've got a nice topic that you'd like to write about, for instance, what you talked about, Chuck, would be an excellent item. We'd love to have those published in our newspapers.
I could make a comment there.
Yes.
Al came through just recently with an article that I have not seen yet in the newspapers, turned in last week, I believe, but he updated a previous article from several years ago about what's is there up in the summer sky to observe. And that kind of article has proved to be very popular with our readers of the newspaper. So I'm going to be looking, possibly doing one for the late summer articles, objects to observe in the sky. And you might want to consider doing something like that. Just basically notes from what you've been observing at certain times of the year and what's interesting up there. Newspapers like to have that kind of thing. It applies to the general public where they can look up in the sky, see what's there, see what the names of some of the constellations and clusters in that are. So please consider providing one of those articles for the local newspapers.
Sounds good. All right, excellent. All right, so now again, kind of going over some of the same things again. We've got Carl Winning on August 7th. We've got our PAC picnic, which is coming up August 12th, which will be at the Paul Castle Observatory. And did you have some information for us on that? Would you like to come up and share that with us, please? Thanks. Let's speak to this. Yes.
Okay, August 12th, 6 p.m. at the Paul Castle Memorial Observatory is our annual picnic, and that's also supposedly a good time to view the Perseid meteor shower. This year, the moon is going to set about dusk time. It's not a very full moon. It's a waxing crescent moon at that time, so the light ought to be very good. Now, if we can just get good weather for the rest of it. But there's a few things that I do need to have done along the way. I need a few people to contact me if they're willing to do this. I need someone to bring some charcoal and get the grill fired up. Now, if we start people coming in at 6 o'clock and they're bringing hot dogs or hamburgers or steaks or whatever, and you want them grilled, go before that, we need to get the grill going. Probably we'll need 2 or 3 tables for holding dishes to be passed, because later I'm going to tell you that besides bringing your own meat, you might want to bring something else to share with everybody. And then toward the end, we need the hauling of the cans and bottles away and the handling of the rest of the wrappers, things like that, be taken away. I appreciate that. Also, it may not sound serious, but we got to have someone to protect Pam from getting stung by bees. Because last year, bees seemed to like the empty pop cans, and she was over by the empty pop cans and got stung. She wasn't very happy about it.
No, but I'll bring my bottle of Benadryl just in case.
Anyway, so you're going to bring meat for your own meal. You're going to bring your own non-alcoholic beverage and your own chair. Bring those things along. Contact me if you're willing to do any of those earlier things. We appreciate it very much. Thank you.
All right, thank you very much. All right. All right, other meetings coming up here. We have a board meeting on September 10th. And then on September 11th, here at Butterworth Center, we're going to have our smorgasbord talks again. So if you have something you'd like to discuss, a topic that you'd like to share with the rest of the club, let me know, please, or other board members, and then we'll add you to the list of people for the smorgasbord talks. October 14th, we have our annual banquet, and this is going to be at Riverfront Grill. And we're still looking at a speaker for that one. We had a couple of people in mind, but they're going elsewhere because we have a number of the solar event. Is that correct, Al? That's coming up.
There's an eclipse.
Yes, there's an eclipse coming up, and unfortunately, we're losing some of the people we'd like to have speak, but we're still looking for a good speaker for October 14th for our banquet. Then November 13th, again at here Butterworth Center, we've got Val Gurman, and going to be talking about astronomy on the Santa Fe and Oregon trails. It's going to be a nice little history lesson, among other things, so I think it's a good one to hear. And then December 11th, we'll have the year in review. Always some fun things with that one, so we'll see who gets the prize at the end of the year, but we'll see how we come out, right? Now, we're going to adjourn in a little bit, but before we adjourn, just some quick things again. We do have t-shirts which can be picked up for new members and for members who need them. Again, we've got the Abbey Zoo on the 15th, the Witt Library the 25th, Carl Wenning on August 7th, the picnic on August 12th, and the next meeting September 11th. But we do have some observations to share with everyone. So I'm going to stop screen sharing at the moment here. I've got a couple quick ones. And Al, you've got a number of items to share with us as well. Is that right?
Yeah.
Good. Okay.
And I finished 2 from last night.
Excellent. Yes, I'd like to hear, Byron, would you like, let me run through a couple of these quick ones and then I'll have you next. And then we'll have Al after that. How's that sound?
Very good.
All right, great. Do a quick screen share here. All right. A couple of quick things here. So just a moment, please. Okay. This is a shot of the sun. Is this, I believe this is one that Roy sent us here this month. Roy, would you give us some information on it?
Well, the big spot down at the bottom, I think it's actually 3353, is so large, several times larger than your that from Mars. And the photograph was a very important.
So it's quite a large sunspot.
That is a very large one. There's probably about 12 sunspots, groups on it. They can blow it up, and we can see them all over. So we're headed towards solar maximum, so that's going to get more active. Really kind of neat.
Yeah, that's good. I know we're going towards that, but it still seems not there yet. It seems you're a little suppressed yet, but it's approaching.
25,
yeah. Good. Excellent. Okay. And here's another one. That's a close-up view of that same sunspot. All right. And again, I think this is the.
I think that was taken today.
Today,
the large sunspot is supposed to start breaking into 2. At least I think so. I can't see it with white light, but I'm just wondering. The picture I saw of it was with the height and alpha, and it showed a light bridge between the 2. So it's like I might be lighting up into 2 sunspots.
well, it does look like almost 2 spots, kind of with a drawn-out span between. So
yeah,
very close.
Yeah.
All right. And now let's stop to share quick. Get another one real quick. This won't take long. All right, on the 7th of this month, Friday night, even though it was cloudy, we took the PAC out to the alpaca farm. And if you remember, we've been out there a number of times and we've seen quite a few things, and that's Mr. Meow the cat. Sorry, not a lot of stars to see in this one. And there he is, a little closer. Oh, here, let me get that up. Screen share. And see there. There we go. All right, there we go. There's Mr. Meow the cat at the alpaca farm.
He wanted to go home with you.
He did. He actually hopped in my car for a little while, liked it, and then hopped back out again. And Ellen, when I texted her about it, she said, "Oh, bring him home." I said, "He likes it." This is Galileo, an alpaca. We remember from some time ago. He's actually the host alpaca, and he's been around for a little bit. A very nice gentleman. There we go. Here we've got the mobile observatory up. You can see Rusty setting up his telescope, and a few of her members, of course, on the side. And this is the alpaca farm itself with about half the guests. I think they had about 50 people show up that evening. So actually, they were very appreciative that we showed, even with the clouds. Does this mean they did not have to cancel a number of their reservations? And if they cancel reservations, they have to refund the money for them as well. So with 50 people, it worked out quite well for them. And now this one, bring him up here. This is Ganymede, which is Galileo's son. And 2 years ago, when we were there, Ganymede had just been born the day before. So here he is 2 years later. That's it. Stop to share quick. One more share, and then I'm going to be out of here. A second here. Okay, a couple of quick photographs from Saturday night. Here we are at Linewick Park, with the mobile observatory set up. A couple of the telescopes up and ready for view. Rusty with his, of course, on the end there. And Al with the club scope. And that's it for my sharing. All right, now, Byron, if you'd like, why don't you go ahead and share some of your screens and let's see some of the photographs that you have tonight and give us some details.
Okay, let me find what I need to get here. Okay, the first one is M16 on my son and 17. I was able to get both of these in one frame and then cropped them in, but it's 2 hours of exposure. Are you seeing both of them or just one of them? There they are. Does that flip with my screen?
Yeah, that looks nice.
Beautiful.
So yeah, those would really pop with probably another 2 hours of data, but that's pretty good for starters. That eagle is very apparent.
Did you use your Canon?
Yes, I used that 60 Mark II and the Takahashi.
How much total exposure time is that, Byron?
2 hours. So that was 40 frames at 3 minutes each, 1600 ISO. So not bad for 2 hours, and it was just prime conditions last night. If I didn't have to get up to work, I would have stayed there and got 2 more hours.
Yeah, excellent photos.
Thank you.
Do you have any others you'd like to share with us?
No, that's just the 2 that I have. I mean, it was just one shot I took. Like I say, I was wanting to do one or the other, but when I took the first test frame, I could see I could get them both in there. So I just kind of, moved the scope and got the auto on-camera auto guider going, and it was framed in there nicely where I could crop them. So I was happy with that. 2 for 1.
Yeah, so 2 for 1 works very well, very well. All right, thank you. Okay, if you'll stop the screen share, and we'll get on. And then Al, if you'd like to share your screen, please.
Okay. Byron had some really good views there of the Eagle Nebula.
And, no, well, I got this. Chuck, can you see this picture here?
Chuck, can you see the photograph that's on the screen?
I can, yes. That's it.
This is 18 Scorpii. And I didn't know that you were going to be talking about that star. But it's kind of interesting because I attended a meeting of the senior manager of astronomers on Thursday night, and they mentioned that this star is virtually identical to the sun. Same power emission, G-type star, same mass and everything. And that is 45 light years away. And at magnitude 5.5, basically, you would have a hard time seeing it with the naked eye. But that's what we would look like viewed from a distance of 45 light years. We'd be very, very faint. Yep. Let me see what else I have here. I've got a lot of pictures here. These are some from. I took that picture that night that we were at Limelight with the telescope. So these are some pictures I have from the line here.
What telescope is in the mobile observatory?
We have a 12-inch LX200.
Nice.
And it's nice. It's fairly nice scope. Right there's the telescope right there, and that's the group that we had there. Rolling Dino, Rusty Cage, Dino Malani, Dan Cusack, my wife Sarah. This is Pam Polar and Ava Davison and myself there. And I think John Douglas came after this picture.
Yes, he did.
As well. I don't know if there's anybody else there or not, but we had like 5 or 6 telescopes set up. And
Well, Dale and Joanne showed, but a little
yeah,
later, yes,
Dale and Joanne
for a little bit, yes.
Yep. And this is particularly the best picture of M22. But this is the difference between the kind of photography that Byron does and the kind of photography that I do. I take a 10 or 15 second snapshot and then I move on to the next topic. So this is the kind of image quality you get. But,
You're also displaying too to the public too, because you're showing it on the screen so everyone can see it at that moment. They don't want to wait 3 hours, so a 10-second shot works very well.
Here's the dumbbell nebula. This is also it's probably a 15-second time exposure, and it's really amazing when you throw those images up on a widescreen TV for the public to look at it. They're just flabbergasted that you have something out there in color. You can actually see these colors. And green nebula, of course, everybody's favorite. Before we were set up before sunset, so this isn't necessarily the best picture of the sun that shows that same very large sunspot that Roy had. Roy's picture is a lot better than if you're ready to show the public that. What else I have here? I think I got some pictures here. I got some pictures from Dan Cusack here also.
You had a really big one in
Okay, there. Everybody took a group picture. I think what do we have, about 100 visitors?
I think it might be actually more closer to 150 total. But it was spread out most of the night.
Here's Dan's picture. I think this is Dan 22 here. I don't know. Dan, you're online.
Yeah, I'm on here.
Anything you want to say about your photography, Dan?
Well, yeah, I don't know. Those are taken with the ASCAR 500 with a field flattener in it, and they're 1 minute exposures, and they're stacked 30 exposures on them.
Cool. Is there a galaxy?
Yeah, the Pinwheel Galaxy was in there.
Yeah, I was looking in the picture there. It looks
Oh
like,
yeah, I'm not sure which one that is.
I never noticed that before. Yeah, there's your pinwheel. Very nice. And that supernova is still visible, isn't
Up in that upper left arm.
it? It's like right up. I don't think you can see it on my screen or not, but right off on my finger is. And then this is the Pelican, right?
Yeah, that's the people like that one the best.
That's amazing.
Yeah, I'm pretty happy with it, seeing how it's only 30-minute exposure, you know.
Yeah. And you took that during the public observing.
Yeah, I had it displayed on the screen for him.
That's great. Let's see what else I had too. I had a picture from Mike Mack, who was a former member. This is M13. I think this is a surprise for a lot of ways.
There was an IC galaxy in that previous picture. I forget them. It's in the upper left,
Yep.
Okay. Yeah.
International Catalog Object.
How many stars are in M13?
Several million, aren't there?
There's a lot. A lot. Let's see what else I can show you here.
Do you have that M22 I sent you, Al?
Yeah, hang on a second. This one? No, that's a big picture. Maybe I don't have it.
Yeah, it was from last night.
Oh, no, that's M13. That's M13.
Yeah, it would have been from last night when I was testing on that other scope. That's all right, no biggie.
Yeah, I don't know if I have that or not.
Yeah.
That was from last night. So that was right here. No.
Oh, there's that gamma. Yeah, that's my gamma Cygni.
That's yours, isn't it, Byron?
Yeah.
What is this? A picture of?
Gamma Cygni. So, yeah, on Cygnus, they're kind of in the center of the cross.
That's amazing. Who's this? I don't remember. This is.
Yeah, it looks like the one I shot last night.
So it looks like M22.
Yep.
Very nice. You said you don't think you have the correct back focus, but well, I can't see anything wrong with that.
Yeah, you can't tell until you blow it way up and then look in the corners.
These are voice pictures. You're doing some great solar work, Roy. I don't know how you're doing it. Wow, that's great.
I can't tell you.
Top secret.
It's top secret.
Okay. And what's this one?
This was Arcturus. I think somebody, Danny.
Yeah, I sent that to you too. That's what I was using to focus on last night.
Okay. That's a close up, go ahead. Look at the sunspot, man. Nice. And this is M13. Is this yours, Byron, or?
Yeah, that's when I just got the flattener. I was testing it out on something simple. Yeah, I've already had to, I took that with the Takahashi, so it's already cropped quite a bit because it's pretty small in it.
Yeah.
M1
one also, that's nice.
Yeah.
Nice shot. Very nice. I could probably bore you to death with pictures, but let's see.
Use Eldridge Library.
Yeah, hang on a second here. I want to, yeah, I'll show you Eldridge Library, and I'm going to go back to this one here too. I'll show you Eldridge Library. This was a nice session too. We had a lot of people that listened to.
Did you by any chance check that the comments that were put on our Facebook page from the Elder Library? Because there's a lady that was there that took a picture of her daughter listening to you, and she was very, very complimentary.
Well,
Should maybe look at it.
you know, I'm really complimentary of the people of Eldridge too.
Oh, they're great. They're great.
This is my favorite place to go to do public outreach. The clientele at the Eldridge Library are really top flight people. They're really nice.
I think we took any pictures at the Bible school, we needed 75 people.
No, I didn't take it. This was the librarian here. That's Emily, what's her name? Kate. Emily Kate, when she got married, I forgot what her name was. But she's just the nicest lady. Yeah, no, and I didn't get any pictures.
I sent those to, you know,
Okay.
When did you send them?
this afternoon.
Yeah.
I sent it out.
I was actually in court all day. I was doing testimony in a court case, so I couldn't have gotten. So,
Well, it was kind of late notice that, maybe we can do it a different month.
Yeah,
you can put them up next week.
Here's my Eagle Nebula. That's 25-second exposure instead of 2 hours. But you can still see it. And there's M17. M22 and M27. And this is what I wanted to get to here is the Milky Way last night was really spectacular.
Yeah, even out of Paul Castle. How about that?
This is Paul Castle Observatory here, which we have an 11-inch celestial telescope in there. And it's really a nice telescope. I'd like some other people to come out and use that telescope. I'm usually the only one that uses it. I like to float with it. Oops. And I caught Byron admiring the Milky Way while he was collecting photons. Nice job, Byron. It was really nice last night. It was perfectly calm. The sky, you can see the Milky Way going all the way down to the horizon. You don't see it like that every day around here.
It was pristine, actually. It was really good.
Yeah, this is like a 30-second, or no, I think it was 13 seconds actually. And it may have caught a meteor up here. It's either a meteor or a satellite. I'm not sure. Probably more like a satellite.
I think that's a meteor because see how it's got pointed ends on it.
Yeah,
And it peaks in the center.
yeah.
That's a meteor.
So maybe you're right. One of these, yeah. So it was just really nice last night. I missed out. I was taking pictures of open clusters for the Astronomy open cluster program. So these aren't necessarily award-winning pictures. I was going for quantity. But anyway, you know, a lot of these kind of obscure clusters. You know.
Did anybody else besides me hear on the news tonight when you were talking about possibility of seeing the aurora borealis? Was it Wednesday, Thursday?
They did it to be visible, but I think it said.
Or was that what I thought it was?
I think it's gonna get down to Florida.
Well, they said Indiana,
Indiana, yeah.
in Minnesota, we might get lucky,
Yeah.
because they took some pictures from the view. Not that long ago, but.
Well, we're lucky the weather will cooperate.
Yeah. It's supposed to rain that day here, I think.
It'll rain. It'll rain.
There's this is M13. You can see the propeller. Josh, are you still on there? It's all on.
Not just go.
I think it's.
Doc, have you ever seen the propeller?
I'm sorry?
You ever seen the propeller in M13?
Yes. Actually, it was a large telescope that we used.
Right there.
I think we saw it at Getty Link with a 36-inch.
Oh, wow. That's about all I got. I have a lot of these kind of stars. Some of which are field focused. That's the beauty of visual photography. You can film out from a lane. Anybody else have any things to go?
Actually, making pictures of waiting, but I didn't say.
No? Well, if that's it, go ahead and if you stop your screen sharing there, Al. I think at this point, I think we can stop our meeting tonight unless anyone has something they'd like to share, any other information. I think we're done for the evening. Thank you very much for attending. And let's see you all at our next observation center and keep looking up. Good night, everyone.
That this is about color, activity, right through the